Okay, hey Jordan, here's the circle, circle we have. All right, we're looking at your worksheet now. So your worksheet, you are filling in at the top cosine. You're completing this table. Hold on. Okay. I don't know how to fit this in. Maybe you can see down here. Okay. So you have like x cosine x. It's like negative 2 pi, negative 3 over 2 pi, negative pi, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, I don't know if you can see that. Can you see that? Yeah, you can see that. Okay. All right. So we're actually, to help you get practice, I'm actually going to do sine and not cosine right now. We'll do like one sine or one cosine to help you out, but we're going to do sine right now. So you get some practice. I can't do your worksheet for you, unfortunately. I guess I could, but. All right. So here's what we do. You have your unit circles, so you can just fill them in. So let's start with the positive ones over here, because it's going to be a little easier to do it first. So remember this. Remember, cosine is first, then sine. We're going to look at sine. So sine is in the spot where the y is. Remember, it's x comma y, your coordinate points. So 2 pi is all the way around. So what I mean is, you're starting here at 0, pi over 2, pi, 3 pi over 2, 2 pi. We should write 2 pi here. I don't know why we didn't write 2 pi. Okay, so at 2 pi, which is actually 360 degrees, so all the way around the circle is 360 degrees, which is also 2 pi. And if you didn't know that, you could convert the two and you'd find it. You can convert 360 degrees into radians and you should get 2 pi. So our value in the sine spot over here is 0. So we're going to put 0 there. What about 3 pi over 2? Well, 3 pi over 2 is right here. At this coordinate point, sine is negative 1. At pi, sine is, remember it's the y position, it's going to be 0. At pi over 2, sine is 1. At 0, sine is 0. And then we just keep doing this. So what does it mean when it says negative pi over 2? All that means is that it's a negative angle. So instead of going around clockwise, they're going this way. So you're going to get the same answer whether it's negative or positive, which is kind of cool because when we graph this, you'll see it's very cyclic. So negative pi over 2 you can treat the same as pi over 2. So sine's going to be 1. Negative pi is going to be 0. Negative 3 over 2 pi, sine is negative 1. Negative 2 pi, sine is 0. And you filled out your table. Okay. So I actually want you to go ahead and fill out your worksheet now and do the cosine. I'm just going to add it to the bottom here. So pause the video and fill out your cosine answers. Remember, cosine is just x. So instead of using the second number in the coordinates, you're going to use this first number in the coordinates. So fill in the table for me for cosine. Okay, so for cosine, oh shoot. I got 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. So check to see if you got the same answers as me. This is how you would do it if you wanted to fill this table in using your unit circle. which is really important you know how to do because I don't know how he's going to test you. But you can also use your calculator. So here's a really fast way to check your answers. So on your calculator, I don't know if you have these graphing calculators that we had, but if you just go to mode and change the mode, so change the mode, and you change it to radians instead of degrees, so go down and change it to radians, and then quit out. You can just type in cosine of pi or cosine 2 pi. So cosine, let's try cosine pi. Cosine pi, hit enter. Whoops. It'll give you -1. So let's see, is that what we got? Cosine of pi, we got -1. So you can always do them on your calculator really fast. You don't even need unit circle. But I really wanted you to know how unit circle works, because you can actually get these without a calculator. If you don't know how to convert your calculator into radians, remember, you can still do it because you can just convert pi into degrees. Times when you have a pi, pi's cancel, 180 degrees. So just make sure you're in degree mode. If you're in degree mode, you can just do cosine 180. So if you're in degree mode, you just do cosine 180, whoops, and you get -1, same thing. So you could actually do all these by using your calculator. You don't even need unit circle. But sometimes they'll test you on unit circle, and it's really important you understand unit circle. Okay. Next part, we're going to graph it. Now, I'm not going to graph the cosine function. You're going to graph it, but I'm going to graph the sine function, and it'll look a little different, but it'll still be a wave. So the intercept will just be a little different. But you can do the cosine one. Where'd my eraser go? Oh my god. I'm losing it. Okay, well, I don't know where my, oh, there it is. Okay. Alright, so I'm going to go ahead and graph this now. So remember, I'm going to graph the sine one. You can graph the cosine one. Okay. Okay. I actually don't think we need this unit circle. I'm actually going to get rid of the unit circle. It'd be much easier for me to graph if I don't have this. Alright. So I'm going to try to copy this down here. So we have 1.25, 1, 0.75, 5. Okay. And then here we have like 2 pi. I'm not going to write all these down. I'm just going to write the ones we need. Okay. I actually erased my answers to the sine. So, hold on 1 second. I'm an idiot. So, I'm doing the sine x. So the answers we got were, let's see, sine. Okay, so basically you're going to transfer what you got in your table for cosine on this graph. I'm going to do sine, though. You're going to do cosine. So for sine, the first box is -2 pi. So for sine 2 pi, the answer was 0. So for sine negative 2 pi, the answer was 0. So at negative 2 pi, my coordinate point is going to be 0. So then for u at negative 2 pi, for cosine, it was 1. So for cosine, you would actually put the point up at 1, not here, okay? So then the next one was negative 3 over 2 pi. So negative 3 divided by 2 in decimal form is negative 1.5. So for some reason, these are in decimals, but usually it's in fractions. So just keep that in mind. So sine of negative 1.5 pi, I got 1. So you plot what you got for cosine. We're just going to keep plotting these. That's all you're going to do. So then sine of pi, I got 0. Sine for negative 0.5, I got negative 1. Remember, you can plug in your calculator, double check them. You should get a wave. Now the wave will be a little different for yours and mine as far as the intercept, but you should get a wave that looks something like that. Now for sine, it'll intersect at 0, 0. For cosine, your y-intercept should be a 1. So hopefully that's what you get. So you graph this wave, and then you're going to answer some questions at the bottom of the worksheet. So what we mean by domain is what x values does this wave encompass. For both cosine and for sine, the domain is all real numbers, it's all x's. Because this can keep going. This wave can keep going, and you can keep going. You can go from negative 2 pi all the way to negative 4 pi. You can go from 2 pi all the way to 4 pi. So when you go from 0 to 2 pi, remember, you start at 0 and you go all the way around your circle, that's 2 pi. If you go around your circle again, that's 4 pi. If you go around the circle 3 times, it's 6 pi. So you're doing multiple revolutions around your circle. So this wave can keep going depending on how many revolutions around your circle you're going to do. So the domain is all real numbers. We usually write that. There's different ways of writing it, but you can write an R for all real numbers that has two lines in its backbone, or you can just write all real numbers. Okay. The range is all y values that your wave encompasses. So the range of both this cosine and the sine wave are going to be from a positive, that's the highest the sine wave goes, and a negative one is the lowest it goes. So your range is going to be negative 1, 1. Negative 1 to positive 1. Your period is going to be a full circle. It's going to be 2 pi. All the way around your circle is 2 pi, so it's a full circle. The reason it's your period is because you can cut this wave right here. Let me erase some of this nonsense. If I cut this wave at negative 2 pi, it starts repeating itself again at 0. I can cut it here. This is one wave. It's one period. Then it starts over again. It's repeating. It's repeating the same motion. One period. So one period is 2 pi. Once you start repeating the wave again, you just cut it off. Okay. The x and y intercepts, you know that. The x-intercept here is 0, where it crosses the x-axis is 0. The y-intercept is also 0. Now for you it's going to be a little different because your y-intercept was 1, right? Sorry, the x-intercept is not 0, sorry. The x-intercept is going to be all these points where it crosses the x-axis. So 0 is one of them, but it also crosses at pi, at 2 pi, at negative 1 pi, and at negative 2 pi. So for my sine wave, the x-intercept is one value, it's 0. But the x-intercept, I have multiple values. 2 pi, pi, 0, negative pi, negative 2 pi. Now, for the cosine wave, it'll be a little different. But you can see where it crosses the x-axis and where it crosses the y-axis. And then the max and min values for cosine x. So if you look at your table you filled in, right, the min value is negative 1, and the max value was 1. Okay, that's pretty much the whole table. Now, something to help you with your next worksheet, which you might have questions on, even after this, is to understand that you can use your unit circle, you can use all this knowledge to fill in the cotangent. So if you remember from trig, tangent equals sine over cosine. So cotangent equals cosine divided by sine. So to fill in your cotangent, you're going to be doing a lot of dividing. So what you would do, since we filled in together the sine values for this whole chart, and we filled in the cosine values for this whole chart at the top of your worksheet, you just divide the two numbers. So let's do one together. So the first thing in your chart is negative 2 pi. We know for sine that's 0, and for cosine it was, what was it? For cosine it was 1. We'll do the next one too. For sine, negative 3 over 2, we got 1, and for cosine we got 0. So how do we find the values for cotangent? We're going to fill in the cotangent table. It's just going to be cosine divided by sine. So 1 divided by 0, undefined, no answer. 0 divided by 1 is 0. That's how you're going to fill in your table. Now, the cotangent one that you're going to do has these undefined things. So what do? What do you do at negative 2 pi if it's undefined? At negative 2 pi, if it's undefined, you're just going to put an asymptote there, which is a dotted line, meaning your graph never crosses here, but it gets really close to this line, so your wave will get really close to it, and you're going to have like these hyperbolas. You're going to have asymptotes in your graph. So negative 3 over 2 pi, we got 0, so I'm going to plot this point. But again, you're going to have asymptotes in your graph for cotangent. So see if you can do the cotangent worksheet with that knowledge, but again, email me if you have some more questions. Hopefully this helps. This is a lot of information, and it is really confusing, and it's difficult material, so don't feel bad if it's still confusing. Just let me know, and I can go over it in more detail, a little more clearly. It's hard to listen when I haven't been teaching you. So I did my best, but again, I can spend more time on it. So let me know.